CANTOR'S Math Integral Calculus Part 1 Video number 2. Integral Calculus Part 1 1.4 Integrals of the form integral secant squared x dx, integral cosecant squared x dx. We know that integral secant squared x dx equal to tan x plus c. How? In differentiation, if you differentiate tan x, what will you get? We get secant squared x. Therefore, if we integrate secant squared x, we will get tan x. Similarly, if you differentiate cosecant x, we get minus cot x. Isn't it? Sorry, integral cot x, we get minus cosecant squared x. Isn't it? Then the integration is the reverse process of differentiation. Therefore, if we integrate cosecant squared x, you will get minus cot x. These two are the general form as usual. Now, integral sin squared x, cos squared x will be discussed later. Now, come to problem number 1. Here, secant squared 3x minus 2. You apply this formula. Here, a equal to 3 and b equal to minus 2. Isn't it? The formula is integral secant squared ax plus b is 1 by a. 1 by 3 tan ax plus b. Ax plus b is 3x minus 2 plus c. Next, problem number 2. Cosecant squared 4x. Here a equal to 4, b equal to 0. So, what is cosecant squared ax plus b? Minus 1 by a. Minus 1 by 4 cot ax plus b, cot 4x plus c. Now, come to problem number 3. This can be split like this. Integral 2x minus 3 whole power 1 by 2 dx plus 5 integral secant squared x minus 1 dx. Isn't it? Here you apply this formula. Here a equal to 2, b equal to minus 3, n equal to 1 by 2. What is the formula? The formula is 1 by a. That is 1 by 2, 2x minus 3 whole to the power n plus 1 by n plus 1. That is 1 by 2 plus 1 by plus 1 is 3 by 2 by n plus 1 is 3 by 2 plus c. Plus 5 secant squared x minus 1. Here a equal to 1, b equal to minus 1. The formula is 1 by a. 1 by a is 1 by 1 is 1. Tan ax plus b. Tan ax, that is x minus 1 plus c. That's all. Integral calculus part 1. 1.5 Integrals of the form integral secant x tan x dx and integral cosecant x cot x dx. We know that d by dx of secant x is secant x tan x. And integration is the reverse process of differentiation. Therefore, if you integrate secant x tan x, you will get secant x plus c. Similarly, integral cosecant x cot x dx equal to minus cosecant x plus c, and these two are the general form. Come to problem number 1. The problem can be written as sin x by cos x is tan x. Again, 1 by cos x is secant x dx. What is integral tan x secant x dx? This is equal to secant x plus c. Problem number 2. Here a equal to 2 by 3 and b equal to 0. Secant ax plus b into tan ax plus b is 1 by a. 1 by 2 by 3, that is 3 by 2. Secant ax plus b, secant 3x by 2 plus c. Problem number 3. Here a equal to 1, b equal to 3. Integral sin x plus 3. What is sin? Sin becomes, that is 1 by a, that is minus 1 by a cos ax plus b, isn't it? Now we apply that. Minus 1 by a, it is minus 1. Sin becomes, it is cos x minus 3 plus c, x plus 3 plus c. That's fourth one is left to you. Integral calculus part 1, 1.6 integrals of the form integral 1 by root of 1 minus x squared dx and integral 1 by 1 plus x squared dx, etc. Here we know that d by dx of sin inverse x equal to 1 by root of 1 minus x squared and d by dx of cos inverse x equal to the same thing with the minus sign. Also, we know that integration is the reverse process of differentiation. Therefore, if you integrate 1 by root of 1 minus x squared, you will get sin inverse x plus c. Also, the same integral 1 by root of 1 minus x squared equal to minus cos inverse of x plus c. Here this is the general form. Next, we know that tan inverse x, if you differentiate tan inverse x, we will get 1 by 1 plus x squared. Therefore, integral 1 by 1 plus x squared dx equal to tan inverse x, or This is minus cot inverse of x plus c. The third one, integral 1 by x into root of x squared minus 1 dx equal to secant inverse x. Why? If you differentiate secant inverse x, you will get 1 by x into root of x squared minus 1. And if you differentiate cosecant inverse x, you will get minus sign, minus 1 by x into root of x squared minus 1. Therefore, integral 1 by x into root of x squared minus 1 dx has two formulae. One is secant inverse x plus c, another one is minus cosecant inverse x plus c. Now come to problem number 1. Here, integral 1 by root of 1 minus 2x whole square. This compare with this. Here a equal to 2. The formula is, you can write 1 by 2 sin inverse 2x plus c, or minus 1 by 2 cos inverse 2x plus c, isn't it? Now, problem number 2. Here this you have to write like this, x into root of root 3x whole squared minus 1. Now compare with this. Here a equal to root 3, and you apply this formula. That's all.